Hi everyone, today we're going to take a look at arithmetic combinations of functions. So we're going to learn how to add, subtract, times, and divide different functions. And to begin with, take a look at some of the function notation. You're going to notice that some things look probably a little bit new to what you've seen in the past, and there's multiple ways to be able to represent this. So the two blue boxes are going to show a couple of the different options. But basically, if you have an f of x function and a g of x function, if you added them together, it could just be something as simple as saying f of x plus g of x, like we have right here. Or you could write something like this, where you have f plus g all in a bracket of x, and they mean the exact same thing. So you could do that to add functions, you could subtract functions, you could times functions, or you could divide functions. And so a common terminology would be to see what you have in this first blue box, but sometimes they'll do something in which you don't even see the x's, and so it could be something as simple as just saying f plus g or f minus g or something like that. And if that's the case, they're still just adding two functions or subtracting two functions, and then same thing here where you can times functions and divide functions. Okay, so given something like that, here's some common questions. This is going to be review for Math 10, and basically it's just a fancy way of being able to do some substitution. So for 1a, if they say something like f of 3, what you would say is, it used to say f of x, but wherever there's an x, I now am going to have a 3. So you could look at your regular f of x statement, and then you could say wherever there was an x in this statement, I'm just going to replace it with a 3. And if you do that, you would get a statement that would look something like this. Our x's are now 3's, and if you just apply the proper BEDMAS, you would get 3 squared, 9 times 2, 18, minus 9 plus 1, and then that's going to give you 10. Okay, so nothing too tricky here. What I would do is I would pause the video and I would see if you could find out the next 3. Okay, so here we put in -1s wherever we see an x for our g of x statement. And so you would end up with something that would say -5 plus 2, that's going to give us -3 right there. Okay. G of 0 plus f of 0, you could actually do this pretty quickly, because if you put in zeros in your g of x statement, you'd be left just with this back term here, the constant. And if you put in 0 into your f of x statement, again, you'd be left with just your constant. So we know, without even having to write everything out here, that your g of 0 value is just going to be 2, and your f of 0 value is just going to be 1, and so together you're going to get 3 for something like that. And then for a quarter here, you could just substitute that in. And if we do something like that, well, we would end up getting 2 times 1 over 16. So I'm just going to say that's 1/8 in a reduced form, minus 3/4 plus 1. And then you want to get a common denominator just to be able to join everything here. So taking a look at what we have here, we could get a common denominator of 8. So times 2 times 2 times 8 times 8. And we would get something that would say 1 over 8 minus 6 over 8 plus 8 over 8. And that would leave us with -5, 3 over 8 right there. Okay, so all we did was just substitute in some values, and hopefully you guys came up with something exactly the same. Okay, let's move on. So the next thing that we could do is we could take a look at some of these expressions right here. And this is saying f of x plus g of x. So we're not going to come up with a numerical answer, but we're going to have something in terms of an x. And if you have f of x plus g of x, this is just saying that we're going to take 2x plus 1 and we're going to add it to x squared minus 2x plus 1. And then we want to expand and simplify that. So we want to write it in a simplified form. And if we do that, we could say, well, we would have an x squared. 2x minus 2x would actually go away with each other. And then the 1 and the 1 you could join. And you would get something that would say x squared plus 2. If we have h of x minus k of x, something like this. If this looks weird, just remember it's the exact same as saying h of x minus k of x. And our h of x value is going to be x cubed, and our k of x value is going to be 2. So we have x cubed subtract 2. Here we have k of 3 times g of 3 all over h of 3. So if you had something like k of 3, I'm just going to say, just to make sure that we're all on the same page, understand it means exactly the same as saying something like this. So k of 3, well, k of anything is always just going to equal 2. It's a constant answer. So you're going to say this is going to be equal to 2, and then our g of 3 value, well, if I put in a 3 where I have my x's right here, I would get 9 minus 6 is 3 plus 1, I'd get 4. And then h of 3, well, if I put in a 3 right here and I cube it, 3 cubed is 27. So I would end up with something that would end up being 8 over 27, and that would be our best final solution. For our next one here, we have f of 1 times k of 1 minus h of 2 times g of 2. Okay, so we sub in a 1 in our f of x statement for x, and we would end up with 3. K of 1 is going to be 2. H of 2 is 2 cubed, which is 8. And then g of 2 would be 4 subtract 4 plus 1, so just a 1. And we would get 6 subtract 8, which is going to simplify to give us negative 2. And then finally for our last one here, this is it's saying, well, what would you get if you had h of x times by f plus g of x? And we could do this entire question from scratch, or we could say this. I actually know most of the answer because in part A, we solved f plus g of x. And f plus g of x was just x squared plus 2. So if we just have x squared plus 2 and you times that by your h of x that's in front of this, our h of x is just going to be x cubed. So all we have here is we have something that's going to say we have x cubed times by my answer to part A, which was x squared plus 2. And we can expand that, and you could get x to the 5 plus 2x cubed. And then you could solve it a lot faster than you would have if you had done it from scratch. Example 3 looks more challenging than what it is just from a first read. It's actually a fairly straightforward question. We're saying here if h of x is equal to, and I'm just going to rewrite this by saying f of x plus g of x, find out what would happen if you know what f of x is and you know what h of x is. So where we have h of x, we can replace this by saying it's x squared plus 5x minus 2, and it's going to be equal to f of x plus g of x. And they want us to solve for g of x. And that's just another way of saying get this g of x isolated. So subtract 3x onto the other side and add 4 onto the other side. And if you do something like that, you would get x squared plus 2x plus 2 is equal to g of x, and that would be our simplified statement right there. So it's just a way of saying, can you isolate for part of your equation? Whoops. Okay, let's look at a couple graphs. So for these graphs right here, g of x is this lower function right here, and f of x is the part that kind of looks like an absolute value right there. And so if they're saying something like this, I'm going to do one of the rows, and then I'm going to see if you can solve the remaining rows. If you look at something like this, here's our f of x function. It's saying find what happens when x is at -5. So you would go to an x value of -5, and you would travel all the way up until you're right here. So that has the x value of -5, but it produces a y value of 8. Your solution for when x is -5 is an answer of 8. When you're looking at something like g of x and you want g of -5, your solution is 0. It's right here on the x-axis. And so then what they want you to do is, once you've solved for those two, can you add the functions, subtract the functions, times them, and divide them? And so if you add them, you get 8. If you subtract them, you get 8. If you times them, you get 0. And if you divide 8 by 0 right there, then you're just going to end up with something that's undefined. So if that's one of the rows, can you pause the video and can you work on the rows to see if you can find a solution for -4, -1, and +4, and see what you come up with? Okay, so for when we have -4, we get something where this would be a 7g of -4 is at a 1. And then I'm just going to fill in these two columns first. F of -1, f of -1 is 4, and g of -1 is 2. And then f of 4 over here. Okay, so if we're taking a look at, our f of x function, f of 4 is 1, and g of 4 is at 3. Okay, so based off of that, we should be able to do the remaining parts here pretty quickly. We could add them, subtract them, times them, and divide them. And then let's do that for this next one here. If you add them, subtract them, times them, and divide them. F of x minus g of x -2. And times that, we get 3. And we divide them, and you get 1/3. All right. So hopefully that seemed reasonable. Yeah, I don't think there should be too many questions around that. So let's see. Okay, based off of this, let's take a look at the next parts here. They could say something like this: what would be f of -1 plus g of -1? So f of -1, we actually have solved for already. We could look at it right here. And g of -1, we have that right here. So if you wanted to add them together, we've actually already done that, and that produced an answer of 6. F of 0, well, if we want to look at our f of 0 function, that would be right here, and that produced a value of 3, and g of -4 produced a value of 1, so you get something that would just say 3 right there. Okay, let's move on to the last example of the day. Okay, so taking a look at a few of these right here. You might not have a color version, so just to make sure it's all clear, this green function right here, this is f of x right there. And this blue function here, this is going to be g of x right here. And they're saying take your f value, add half of your g value, and create a new graph based off of that. Okay, so create a new graph based off of that. So from something like this, we could say this. I'm going to start with let's start right here. So I'm going to pick a point, and I'm just going to explain how you do one of these, and then hopefully that'll help translate into some of the other options. Okay, so looking at the f of x function, this has a value of 0, 0. And looking at the g of x function, that has a value of 0, 3. And what they're saying is you need to half your g of x function. So it means that your solution, your output, your y value, when you used to have the 0.03, it's now going to produce an output that's only half of that. It's going to be at 1.5. And if you add that to this 0 value, you're going to get an answer that's going to be right there at 1.5. Okay, and I got that by going 0 plus half of 3. So you're taking common x values, and then you're going to find out what their new y value is going to be. Let's do another point here. Okay, so let's say if we have something like, well, let's pick this guy here and this guy here. Okay, so looking at my f of x function, if I have a y value here of 2, and then looking right here, if I have a y value of 1, it's going to say I'm going to take my f of x current value, which is the 0.22, and I'm going to keep this 2 value, and I'm going to add that with half of my g of x function. And if that has a y value of 1, half of 1 is a half, plus the 2 would make a total of 2.5. And so my new point for when I have x values of 2 would be at 2.5. So I'm taking the 2, adding half to it, right there. Imagine what would happen, say, over here when you have something like an x value of 4. So if you have something like that, and you have the point 4, 4, and then over here you have the point 4, negative 1, you're going to retain the exact same y value for your f of x function, and then you're going to half your g of x. So half of negative 1 is negative a half. 4 and negative a half would make 3.5, and you'd be right here. And you should notice that the 3 points that you've formed so far, you're going to make a line like that, and so you could join them. Okay, so then I'm going to pick one more point over here just to see if it's consistent, and it will be. So this point here, when I'm at negative 3 for my x values, my f of x function has a y value of 3. My g of x, if I has a y value of 0, and if I half that, it stays at 0. So then I would create something that's going to actually stay right here. And if you feel good about that, it probably means that you have enough information to join it like that. But if you wanted to double check, we could always do another point and see what happens from something, if you want to just see if we're still on the right track. So for instance, with something like right here, this has a y value of 1, and that's going to stay at 1. And this has a y value of 2, and you need to half that. So it's going to be the point, that's going to be half to a 1, plus I already have a 1. So they add up to a total of 2. So it was definitely in the right spot. And we've just created our new function, and that's all it is right there. Okay, now I took a look at some of the homework, and I just want to trim this down a little bit for you guys. So number 5, there's a couple errors in there. So actually I want to make sure that you don't get stuck doing all of those questions. There's, I think, forget if it's 5E or something like that. I know there's for sure at least one error for what you have to worry about. So what we'll do is we're going to say this. We're going to omit all of number 5, and we'll actually omit 8, 8B and D as well. So if you just worry about these guys, that's more than enough. plus you have these questions right here, and that's your homework. So thanks. That's section 2.2.